There are different ways to solve problems that involve probability. In all of the following examples, we're going to be using this equation. To calculate the probability that event A occurs, you need to take the number of ways that event can happen and divide by the number of possible outcomes in the sample space. Here's an example dealing with a standard deck of cards. To calculate the probability of drawing a club when one card is just randomly drawn from a deck of cards, we need to know how many ways a club can be drawn. Well, these are all the clubs. There's 13 of them. So there's 13 ways a club can be drawn. The next thing we need to know is how many possible outcomes are there in the sample space? Well, here's all the possible outcomes. There are 52 possible cards that can be drawn. So the probability of drawing a club is 13 out of 52. And that reduces to 1 out of 4, which is 25%. Next, we're asked to figure out the probability of drawing a jack. So we need to find all the ways you can draw a jack. Well, there's 4 ways you can get a jack. You can have a jack of hearts, a jack of clubs, a jack of diamonds, or a jack of spades. So there's 4 ways you can draw a jack out of 52 possible outcomes. In lowest terms, that's a 1 out of 13 probability, which is about 7.7%. To find the probability of drawing a heart, a club, or a queen, I need to add the probability of drawing a heart, and the probability of drawing a club, and the probability of drawing a queen. There are 13 hearts, and there are 13 clubs, and there are 4 queens. However, 2 of those queens have already been included in the hearts and the clubs. So really, we only have 2 more queens. And again, there are 52 possible outcomes in our sample space. So that's a probability of 28 out of 52, which in lowest terms is 7 out of 13, which is about 54%. The next question is asking about the probability of drawing an ace or a face card. And it's important to remember what a face card is. It's any card that has a face on it, a jack, a queen, or a king. So we're really looking for the probability of drawing either an ace, a jack, a queen, or a king. There are 4 aces, 4 kings, 4 queens, and 4 jacks. And the total possible outcomes are still 52. So that probability is 16 out of 52, which reduces to 4 out of 13, and that's about 31%. The last question is asking about drawing a red or a black card. So if you look at the deck of cards, the red cards are the hearts and the diamonds. So there's 26 red cards. The black cards are the clubs or the spades, so there's 26 black cards. And there are 52 possible outcomes in our sample set. And if you're keen, you'll notice that's all of the cards in the deck. So there's a 100% probability of drawing either a red or a black card. There are lots of different questions you can ask about rolling dice. So if you're rolling 2 dice at the same time, you can figure out the probability of getting different outcomes. On the right-hand side here, I've drawn a chart for you to show the possible outcomes of the first die that you're rolling and the possible outcomes of the second die that you're rolling. In the middle, these are the sums. So if you rolled a 1 and a 1, the sum would be 2. If you rolled a 2 on the first die and a 3 on the second die, your sum would be 5, etc. So to calculate the probability that you're going to get a sum of 7, you need to figure out how many ways you can roll a sum of 7. Well, you can roll a 1 and a 6, a 2 and a 5, a 3 and a 4, a 4 and a 3, a 5 and a 2, or a 6 and a 1. So there are 6 ways you can get a sum of 7, and there are 36 possible outcomes for this sample set. So the probability is 6 out of 36, which is about a 17% probability. To find the probability of rolling doubles, we have to figure out what that means first. So it's when both dice have the same value. So you can roll a 1 and a 1, a 2 and a 2, 3 and a 3, 4 and 4, 5 and 5, 6 and a 6. So the probability is the same. There's a 6 out of 36 probability, which is about 17% again. To find the probability that the sum is 3 or 11, well, there's 2 ways the sum can be 3, and there's 2 ways the sum can be 11. And there's 36 possible outcomes. This works out to be a 1 out of 9 probability, or 11%. I want to show you a way you can use a tree diagram to solve probability problems. So the question is, what is the probability that when you flip a coin 3 times, heads will occur twice? So first you have to remember that when you flip a coin, you can either have heads or tails. And I'm going to construct a tree diagram for all 3 flips. So for the first flip, I can either have heads or tails as the outcomes. And for each of those outcomes, I can have heads or tails for the second flip. And for each of those outcomes, I can have heads or tails for the third flip. So if I want to know the probability of flipping the coin 3 times and getting heads twice, I need to count how many times that happens. Well, let's follow all the different pathways. So we can go heads, heads, heads. That's not 2 heads, so that doesn't work. Or we could go heads, then tails. Well, if we follow that pathway, we get heads twice. If we follow the next pathway, heads, tails, heads, well, that's a total of 2 heads. The next pathway, heads, then tails, that's only 1 head. And we can keep doing that for all the different pathways. So you can see there are 3 outcomes that give 2 heads, and the rest don't. So the probability of flipping a coin 3 times and getting heads twice is 3 out of 8. Here's another question that deals with the same situation. What is the probability that when you flip a coin 3 times, heads will occur at least once? So the key to this question is at least once. So it's really asking the probability that you are getting 1 or 2 or 3 heads. So you could analyze your tree diagram and add the probability of getting 1 head and the probability of getting 2 heads and the probability of getting 3 heads, but that's a lot of work. What we can do instead is use the complement. So to get the probability of at least 1 head, we can just take 1 minus the probability of no heads. So if I go back to my tree diagram, there's actually only 1 way that you can't have any heads. It's if you get all tails. So there's only 1 way out of the possible 8 outcomes. So we can just do the math, and there's a 7 out of 8 probability that you will get at least 1 head when you flip a coin 3 times.